Here we go. So we're going to start with qualitative chemical analysis. Here we've got definitions of qualitative and quantitative. But does anybody know, can anybody give me a gut feeling or an intuition or a description of the difference between qualitative and quantitative? No? Have you ever heard the terms qualitative and quantitative before?
Quantitative is a noun and qualitative is...
Yeah. It's hard to define qualitative. It really honestly is. Quantitative is number, an amount of something. So quantitative, you have to give me some sort of a value. 3 apples. That would be a quantitative description of apples. You have 3 apples. Or the total mass of apples is 170 grams or something like that. That would be quantitative descriptions or quantitative analysis. Qualitative descriptions, quality. So these apples taste good. What's another qualitative description you could use for apples? What was that, Luke? They taste bad. Somebody, hey, let's get off the good-bad train and give me another qualitative description of an apple. Okay, sour, bitter. What? Red, green,
black,
ripe, black. Okay, sure. Do you know what I mean? So, qualitative is often a little bit subjective. So there's a little bit of interpretation when we talk about qualitative. Whereas quantitative, is there any interpretation? I mean, if I brought out 3 apples, could you all agree that there were 3 apples? Yeah. If I brought out apples, a batch of apples, and they were all totally identical, and then you all took a bite out of separate apples, we're not gross, okay, but you took a bite out of separate apples, could you all agree on a qualitative description? Would everybody agree, oh yeah, the apples were good? No, probably not. Okay, because some people just straight up don't like apples. So qualitative descriptions include descriptive terms that can be used to discriminate between 2 substances based on your senses, right? So an example is, that liquid looks blue. Now, I'm intentionally making this very simple because when you have a blue liquid, can you very easily discriminate between that liquid and another liquid? Yeah. Oh, that one's blue. That one's not blue. So I know something about this liquid that happens to be blue, that kind of thing. Quantitative observations must include a numerical description of a substance. So, for example, that liquid has a density of 1.03 grams per cubic centimeter. Do you see the difference between a qualitative observation and a quantitative observation? We measured the density to be 1.03. Is there a lot of interpretation? Is there a lot of subjectivity when we calculate density? If you put this liquid into an instrument that would measure density, do you think for the most part we would all get the same density? Maybe. If we used the same instrument, if you put a sample of this liquid into an instrument that measured the density, and then Jenna did it, and then Maddie did it, and then John did it, and then whatever, do you know what I mean? If you all used the same instrument, do you think you would get approximately the same value? Yeah, that's right. But if we looked at a liquid, now blue is a fairly subjective term. Are there different types of blue out there? Yeah, so what's blue to you might be blue-green to somebody else. So there's a little bit of room for interpretation on those things. But anyways, that's the basis of qualitative versus quantitative. Quantitative, every single time you're using a number, you have to use a number. That's the definition of a quantitative measurement or observation. You weighed out 2 grams. Is that a quantitative or qualitative measurement? Quantitative, right? 2. All of a sudden, you see a number, boom, done. That's quantitative. Okay, of the types, today is all about qualitative observations and qualitative analysis. Of the types of qualitative analysis that we can do, one is called colorimetry. And any metry is like measuring. So what are you measuring here? Color. You're measuring color. Now we're not actually measuring color. There's actually specific ways to measure color, but here is very basic measuring of color. The idea of using a color of a solution or a flame to assess the identity of a substance. We can tell the difference between that substance and that substance. Now, I didn't expect these 2 substances to look so similar on the smartboard. They're not supposed to look this close. I think there's just a really crummy bulb in here. Okay, what color is this supposed to be?
Green.
Green, yeah. What color is this supposed to be? Yellow, okay. So that's my bad, whatever. Colors of aqueous ions. What I'd like you to do is take out your data booklet and go to page 11 on your data booklet. And I will do the same thing. If you don't want to, then you can just look at the smartboard. It's basically way at the back.
Why is 9 always so close to 11?
Okay, perfect. So let's think about this. When I look at this table, what do you think is this table trying to tell you? The color of different ions, right? So is chromate the same color as chromium 2+? No, it's not going to be the same color. And so, okay, there's 2 columns here. What's the difference between this column and that column? Okay, in general, what do we call this?
Concentration.
The concentration of the ion. So, which one is more concentrated and which one is less concentrated? First column is more concentrated. This is what we would describe as like, this is concentrated and this is dilute. This is 100 times more dilute than that. Vice versa, this is 100 times more concentrated than that. But whatever. Would you be able to understand if I had a yellow liquid and I diluted that yellow liquid, do you think it would just look less yellow? Yeah, so that's all it means, it's pale yellow, right? So when chromium 3+ is concentrated, it's blue-green, and when it's less concentrated or dilute, it looks greenish. Okay, no problem. What are the 2 substances we are trying to discriminate between? Well, yellow and green, okay. Which of the following pictures, Walton, is iron 2 sulfate, and which of the following is iron 3 sulfate? So look at them. Is the top one iron 2 sulfate, or is the top one iron 3 sulfate?
Iron 3.
It's iron 3?
Two.
That's
3.
This should be pretty easy. Okay, what color are we looking for?
Iron 2.
Is either iron 2 or iron 3, right?
Yeah.
Which one was the top one? It's iron 2, it's green, right? Oh man, classic. So what I would say is that this is iron 2+, right? And then in here, this is iron 3+. Okay, all right, no problem. So could you successfully discriminate or tell the difference between these 2 substances simply based on their color? Yes, okay, perfect. And we didn't have to have a lot of interpretation in there, thankfully. All right, a solution was diluted several times, and the colors of the solutions were compared. Identify the ion that was diluted in the solution. It could be any ion on that entire table on page 11. It could be any ion at all. On page 11, yeah. You tell me, you discuss it with your elbow buddy, okay, or the person behind you or whatever. So try and figure out which one ion we know for sure it's going to be.
They're all the same color.
Yeah, you kind of need, it's going to be pretty hard to tell just based on your notes. With the black and white. Okay, what color? We started off really concentrated and we ended up being really dilute, okay? What color is the really concentrated?
Navy purple.
No, not navy purple. What the hell is navy purple? Yeah, no, it's, would you agree this is a deep or dark purple?
Yeah.
Okay, and as we get more dilute or less concentrated, do you agree it becomes a more pale, so maybe a pink color, that kind of thing? Okay, and then eventually, does it make sense? If I dilute something enough, it'll eventually turn colorless. Would you agree? Yeah, because if you go 1,000,000 times less concentrated than what you started with, right? If you put 1/1000th of a drop of this water into that water, you're really not changing the color, right? So, okay, so what ion is this?
Pomegranate.
Yeah, it's not pomegranate.
Can we say that?
No, you can't. Blueberry, pomegranate,
Mango steam.
permanganate. Perfect. Okay. So another thing that we can do is instead of identifying the color of a solution, we can dip a popsicle stick in that solution, and then we can light it on fire, and we can identify the flame of the ions that we get. Okay? So many metals also produce quite vibrant flame colors. These flame colors can be used to identify the ions and atoms in a substance. So example, turn to page 6 in your data booklet. No. Okay, so here's the flame colors. And what I want you to do, what I want you to try to do is try to, from this list, try to identify the flame colors of the two solutions that I'm going to light on fire.
We do all of them.
What? No, we're not going to be able to do all of them. You're going to do this activity tomorrow. You're going to dip a little wire into a solution, and then you're going to light that solution on fire, and you're going to see a flame, and you're going to have to figure out which substance it is. Flame tests can be used to determine identity of metal or metal ion. Blue to green indicates a range of colors that might appear. Now, here's the problem. What color is potassium? What color is rubidium? What color is cesium? That's not going to be very helpful, is it? But overall, this can be used to distinguish, for example, a yellow flame from like a scarlet red flame or something, whatever, that kind of thing. So what we're going to do, I need the people in this line to move. I need the people in this line to move. If my hands are vaguely pointing at you, Idris, you'll be fine, yeah. Abby, you just have to move temporarily for like 20 seconds, okay? Not 20 seconds, for a little bit of time.
Why are you doing it on my
Okay. The snake is protected by something. He'll be fine. Yeah, we are going to turn the lights off here in a second. Yeah. And I'm going to... I get my really gross counter involved in here, but that's totally fine. Oh yeah, sorry. Okay. The first thing I'm going to do is this is what we call a safety flame. You're going to have to do this tomorrow. I'll run through the instructions on how to do a Bunsen burner thingy later, or light a Bunsen burner later. But that yellow flame that you see there is what we call a safety flame, and that's because it's a relatively safe flame to operate with. What I mean by that is that this is really not like a radically dangerous flame to be around. Right now, it's not that big of a deal, right? I'm not, I'm crazy, that's right. But if I add more oxygen to this flame,
It's close by.
Now put your hand.
yeah. No, thank you. Okay. So what I want to know, can you see this flame really easily?
No.
No, if you were to scan the room really quickly, would you see that there was a flame?
I got good eyes, I guess.
Yeah, you got good eyes. Yeah.
Oh,
Can you see it now?
yes.
Yes, you can see it now. Good. Okay, perfect. So what's going to happen is using your list, what I want you to do is I want you to try your best to identify the metal ions in these two solutions that I'm about to use. Okay, ready? Yeah, I'm going to try to. We'll see how it goes. 3, 2, 1. Ooh.
I missed the weight.
That's so warm. I like it.
Yeah, that's nice. Okay, what color flame is that?
Yellow.
Green.
Oh. That is not a yellow flame. Okay, now, here's the problem. Who's more affected? Who's more affected by color blindness, males or females? Males by far, and that's because typically your typical color blindness characteristic is determined by it's on the X chromosome, and typically males only have one X chromosome, so they are more susceptible to faulty versions of the color blindness gene, or the sight gene. There we go. So that's
Lime green.
yeah, that's green. Okay, perfect. So we're gonna try another one. This other one might stink a little bit, and I apologize. Okay, let's try this. Shh. 3, 2, 1. I mean, you don't have to be quiet. It's not like we're using our ears or whatever, but. That's not bad, hey? So this one, did anybody figure out what this one was?
Or boron.
Oh, wait.
There's a couple different options, right?
Barium and boron.
Okay, barium or boron. Yeah, the second one smells bad. Okay, and what's one of the options for this one?
Lithium.
That's lithium, right? Yeah, that smells bad. I agree. Okay. Thank you for humoring me, Abby. I'm sorry. I hope you understand that I didn't want you to be in the line of fire. It would be toasty, that's for sure. Chemical in your lungs? No, I know. Yeah, I get it. Okay. So yeah, there's a gross smell. That's because it's something to do with the lithium. It's fine. So yes, that second one was lithium, 100%. What were the options for the first one? Okay. Okay. So it could have been barium, yellowish green. Yeah. Okay. Yeah. Sure. Could have been boron, yellowish green. What else is green in here? Copper. Okay. Now let's. I don't know if anybody saw. But what color is this liquid? Okay, so now let's combine a couple things together. It could be barium. Could be barium, copper, or boron, right? Now let's go all the way to the back and let's see. Is barium in here? No. Is boron in here? No. Is copper in here?
Yes.
Are we okay with that?
Yes.
So I need you to understand that on page 6 we read it, right? Blue to green indicates a range of colors that could appear, right? When it says blue to green, it can be a little bit bluer or it could be a little bit greener. In this case, it was a little bit greener. Now, what I need you to understand is there's a chemical that the copper is mixed in with, and the chemical, what color are most flames typically? Like orangish yellow. So there was a little bit of background orangey yellow in there that was always going to be there, right? Because that was the fuel that was burning. So as long as you understand that the copper was burning green, but that green, you add a little bit of yellow from the fuel. You need to understand that. That's okay. I don't know why I put these back. Perfect. So the first one, it was number 1 was a blue liquid with a green, we're gonna say green flame, and the only option was what element? Copper. And then the second one was a colorless liquid with a red. How would you describe that? I want to say red, but
Red.
yeah, red. Okay, red. Red flame. Perfect. And so we know that that was lithium. Wow, that's terrible. Go back to grade school for that one. Okay, so I got a couple questions that I want you to answer me. Riddle me this, please. A dark solution becomes light blue as its concentration is decreased. As it's being diluted, so it's a really dark colored solution, and then it becomes light blue as you dilute it in water. Which of these 4? So answer it, don't say it out loud. Answer it. And then read question number 3 and try and answer that one. Don't say it out loud. It's D. Which one? This one or this one?
Is it that? Okay.
Yeah.
Why would it be?
Again, it's going to be pretty hard for you to figure it out just based on your black and white images. Right?
Oh, sorry. B. I meant B. They're like, sibling. You could turn ED to a B. They're related. No, it's not coincident. Wait, is that B? Is it B? Did you say it is?
You're not the best.
The date?
What does that mean?
Wait, is 2B?
No, Joe.
Okay,
Yes.
let's try this. A dark solution becomes light blue. Ah.
2 for this one. This one.
Okay, a dark solution becomes light blue. Is chromium 2 an option? Yes, is chromium 2 the answer?
Yes.
Okay, all right, good talk. Chromium 2. This lamp uses a vapor of a certain metal and excites it to create the following color. What element is responsible? Is this rubidium?
Yes.
All right. Why? Why is it not sodium?
It wasn't on the list.
Sodium's yellow, right? Or something? Yeah. Lithium's red, boron's green. This is none of those things, so hopefully that's fairly straightforward. Okay, so are you happy with qualitative analysis so far? Using descriptions and things. People are often pretty happy with qualitative analysis. And the reason why is because, have we done any math yet?
I don't want to.
No, and are we going to be doing math with qualitative analysis? No, that's quantitative analysis, right? Qualitative analysis, feelings and butterflies and nice days and snowy and whatever and sunshine. Okay. Solubility is another qualitative analysis. It's got no math involved, but I do want to say solubility is a wee bit harder than colorimetry. So solubility, you have to do a little bit of investigating. You have to know a little bit more about chemical reactions, right? But it'll be fine. Okay, solubility, using the solubility table to identify the presence of a particular ion. Example number 1. A solution has sulfate ions and or iodide ions. So it could have one, it could have the other, or it could have both. Are we okay with that? Perfect. A student adds excess, so like more than enough, solutions of barium nitrate and copper 1 nitrate to different samples of the unknown substance. The results are shown below. Okay, so what I want to do you have a tiny little bit of room at the bottom of this slide?
Yeah.
Yes, you have a tiny little bit of room. Let's take a look at this and let's try and make a little bit of a table. A solution has sulfate ions. What is sulfate? SO4 2 minus. So what I want you to do is I want you to go SO4 2 minus. And then beside it, like give yourself a tiny little bit of space just beside it. What's the other ion that could be there? Iodide. And so we're going to add some solutions to these. And this chart is really, really super duper going to help us organize our thoughts. So, sulfate. Does sulfate do anything with barium? Remember, keep in mind, what type of ion is sulfate? Is it a positive or a negative ion? Negative. So if it makes a precipitate, will it join up with another negative, or will it join with a positive? A positive. So we've got our 2 negative ions that it could be, and we're going to put our 2 positives.
Would all grade 9 students, last name beginning with H and I, please go to room 1603.
I literally can't concentrate if I will pause and stutter and forget what I'm saying. So it's not physically possible for me to do that. Okay, what are the 2 possible positive ions it could be? Which one of these is positive? Barium, and which one of these is positive? Copper 1. So we're going to put barium. What's the charge on a barium? 2 plus. And what's the charge on my copper?
2. I think it's 2.
It
doesn't have a charge. It's 2. No charge.
Wait, no.
It literally tells you.
Oh.
It's been a while since we talked about that, though. Copper 1 plus. I set up the barium in hopes that I would catch some people on the copper, because the more you're embarrassed now about that, or the more you laugh at yourself, the more you're going to remember next time, and that's totally fine. Everybody makes that mistake. Okay, so barium. What I want to know, does barium make a precipitate with sulfate? When we look at our, oh man, I got to go all the way back up here. When barium is added to sulfate. Yes, sulfate and barium, when those 2 things are together, When they bump into each other, they hug each other, make a precipitate, and fall out of the solution, right? So that will make a precipitate. So what I want to put there is I want to put precipitate. Yes, it will form a precipitate. Barium, does barium form a precipitate with iodide? No. No precipitate. Okay. Does copper 1 plus form a precipitate with sulfate? Yeah, let's check using the doubts.
No.
No precipitate. How do we know that? Because it says it. Iodide and barium is not down here, so they do not form a precipitate, right? But what does form a precipitate with iodide? Copper 1 plus. And so this will form a precipitate. So, can you see where we're going with this? We're going to have two different solutions. We have two samples of that unknown, right? That unknown, we poured it into two different beakers. Okay? Now, when we poured barium nitrate, did we form a precipitate or not form a precipitate? We formed a precipitate. So what can you deduce? What was there? What needed to be in our solution in order to form a precipitate with the barium? Which one of these had to be there? If the sulfate was there, would it have formed a precipitate? Yes. So that means sulfate is present. Do you know what present means? Here. It's well, that's a hard word to describe. Yeah. Present means it's there. I don't know. Oh man, my English, no good. Okay, then the reaction with copper nitrate. Okay, does copper 1 produce a precipitate with sulfate? No, it doesn't, okay? And we don't care because we already know sulfate is present. Now, when we added copper, did it form a precipitate with the iodide? Yes, so what had to be there? Iodide. Iodide is present. So when it says, what can you say about the identity of the solution? We can say both SO42 minus and I minus are present, are here. That was way more complicated than the solution's blue, it must be this. You know what I mean? Yeah, totally. It takes a lot more concentration and it takes a lot more intuition. What I'm curious about, did the table actually help you out? Okay, for some of us it might have. Stephanie.
I'm just confused on what you said.
What I would say
And then why you got rid of the nitrates out of that.
is because, okay, I know that our only two options are sulfate ions, which are negative, and iodide ions, which are negative. So is nitrate positive or negative? It's negative. So nitrate will never, ever, ever form a precipitate with these two things. Two negative things don't form a precipitate together. So I just ignored them. Okay, we'll talk about another situation here, and we'll be able to describe it a little bit more. So again, a solution may have the following ions in it: chloride ions and fluoride ions. We don't know. It might have one, it might have the other, it might have both. I don't know. A student decided to add the following solutions and wrote their observations down. This is interesting. What negative ion are we choosing again? Nitrate. And I just for posterity and just to be really explicit about it, does nitrate ever form a precipitate? Does nitrate, any form of nitrate, do you see any nitrate compounds down here? Nitrate is always soluble. Nitrate is such an extremely soluble ion, there's nothing you can partner it with that will all of a sudden make it fall out of the solution in a precipitate. So if you want something to be really soluble, pick something nitrate. If you want a calcium compound to be really soluble, pick calcium nitrate. So that's a little bit of background behind this. That's why you often see nitrated compounds in solubility things. Okay, a student decided to add the following solutions and wrote their observations below. The addition of calcium nitrate, did it form a precipitate? No. Okay. Now what I want you to think about, remember, let's form our table again. What do we care about? Do we care about the metals, or do we care about the non-metals partnering up with these non-metals? Yeah, we care about the metals. So I'm going to put calcium here, calcium 2+, and then I'm going to put silver 1+. So let's do a little bit of background research. Does calcium form a precipitate with chloride? No. There should be no reaction. When I add chloride ions to calcium, I should see no reaction in any way, shape, or form. What about silver ions?
Yes.
Yes. I should see a precipitate, right? So let's think about this. When we added the silver compound, let's look at our evidence. When we added the silver compound, did we form a precipitate? Is this telling you yes we did or no we didn't? This statement. It's saying yes, formation, that was the observation. We formed a precipitate. So what do you know has to be here? When we added silver, there was a precipitate. What do you know has to be here? Okay, let's finish this, whatever. Let's come back to it. Okay, fluoride ions. Do fluoride ions make a precipitate with calcium? Yes. Do they make a precipitate with silver? No. So remember, if I had this sample, and I added silver ions, if we made a precipitate, what do you know has to be present? Chloride ions. If we added silver and it didn't form a precipitate, does that mean fluoride ions have to be there? No. It doesn't mean they have to be there, okay? The only test that confirms whether or not chloride ions are here is whether it forms a precipitate with silver. So, when we added the calcium, did we form a precipitate? When we add the calcium, did we form a precipitate?
Yes. Oh.
So can there be fluoride in our solution?
Yes.
If there was fluoride, when we added calcium, we would get a precipitate, right?
Yes.
Did we get a precipitate? No, so there's no fluoride. Okay, I'm going to have to think of a different way to explain this.
The chart says something.
No, this chart is a prediction. It's not a table of what actually happened. It's a predictive tool.
Yeah. It's predicting if it's going to be.
It's just
It's
predict.
going to have a certain.
Yeah, it's just predicting. Should we get a reaction or should we not get a reaction? Okay. Okay. Let's think about it this way. You don't change anything on your sheet. Just eyes on the board. That's all I need you to do right now. Don't change anything about your sheet. We're going to start over, and you're just going to pay attention. That's it. Chloride ions. Which one of the chloride ions can chloride form a precipitate with either calcium or silver? Which one? Silver. Now, when we added silver, did we form a precipitate?
Yes.
So yes, there are chloride ions present. Does that make sense?
Yes.
Okay. Fluoride ions. What do they form a precipitate with? Calcium or silver? Calcium. When we add a calcium, were there fluoride ions present?
No.
Boom. If it's that easy, then it's that easy. That's fine. You don't have to make a table. That's okay. You don't have to make a table if you don't want to. It's just whenever I look at this, whenever I read this, I have to do a prediction, and then I have to see what do my results match up with. But that's totally fine. Help the student identify if chloride or fluoride ions were present. Was chloride present?
Yes.
Was fluoride present?
No.
Boom, done. Switch. Swish. When we come into class tomorrow, we're going to do the flame test, and then after the flame test, I'm going to get you to answer this question. And if it takes you 15 minutes to answer this question, then by golly, it takes you 15 minutes to answer this question. That's totally fine. You got to be a little bit creative with this. You just got to get creative.